Hello there, my name remains Oladapo and I welcome you to the Global Tutor virtual class. In this video class, I want to teach chemistry and I'll be teaching on the topic chemical bonding. I want to teach chemistry and I'll be teaching on the topic chemical bonding. Let us start the class with this statement. All unstable elements strive to attain stability through chemical bonding. All unstable elements strive to attain stability through chemical bonding. Now the question is now, what are unstable elements and what are stable elements? Now let's see. Stable elements are elements with complete electron in their outermost shell. So any element that has complete electron in its outermost shell is said to be a stable element. Now, stable elements are called noble gases or rare gases. It's either you call them a noble gas or you call them a rare gas. Now, example of noble gas is helium, neon, argon. They are example of noble gas. Now, note, element is either stable with 2 electrons, that is called duplet stability, or with 8 electrons, and that is called octet stability. I will explain in details these two terms, duplet and octet stability. So elements are either stable with 2 electrons or with 8 electrons. The one stable with 2 electrons means it is duplet stable, and the one stable with 8 electrons means it is octet stable. Now, what are unstable elements? Unstable elements are elements with incomplete electron in their outermost shell. So any element that has incomplete electron in its outermost shell is said to be an unstable element. Now let me explain this using the electronic configuration of the first 10 elements. The electronic configuration of the first 10 elements. Let's see. Hydrogen 1, helium 2, lithium 2,1, beryllium 2,2, boron 2,3, carbon 2,4, nitrogen 2,5, oxygen 2,6, fluorine 2,7, neon 2,8. Now remember this formula, always carry this formula with you. The number of electrons in each shell is given by 2 brackets n squared, where n is the number of shell. So meaning in shell 1, for instance, in shell 1, the number of electrons will be 2 brackets 1 squared. That will give me 2 electrons. And this is what we call duplet stability. And only helium is stable with 2 electrons. Others are stable with 8, which is octet stability. Let's look at shell 2. Shell 2. You're going to have 2 brackets 2 squared. 2 squared is 4. 4 times 2 will give me what? 8 electrons. So this one is called the octet stability. So it means the element that has 8 electrons in the second shell would be stable. Let's now go back to this electronic structure. Now, hydrogen here is said to be what? Unstable. Why? Because it has 1 electron. So hydrogen is what? Unstable. Helium is stable. It has complete electron in its outermost shell, which is 2. Lithium is unstable. Beryllium is unstable. Boron is unstable, incomplete. Carbon is unstable. Nitrogen is unstable. Oxygen is unstable. Fluorine is unstable, but neon has 8 electrons in its outermost shell, which is octet stability. So neon is what? Is stable. You see, all these elements that are unstable, they strive to what? To attain stability. They strive to obtain stability through chemical bonding. Through chemical bonding, they strive to attain stability. Now, how does that happen? Now, for an element like hydrogen, it will need one more electron to be stable. So this hydrogen will be ready to gain one electron, and immediately it gain one electron, it becomes stable. Lithium has one electron in its outermost shell. It's ready to lose the electron, because if it lose the electron, it will now be remaining 2 electrons, which is like that of helium, so it will become stable. So helium is ready to lose this 1 electron during chemical bonding. Beryllium is ready to lose this 2 electrons. So if it loses 2 electrons, it will resemble helium, which is just 2 electrons. So beryllium becomes what? Stable. Boron is also ready to lose these 3 electrons. So when boron loses these 3 electrons, the electronic structure will resemble helium, which is what? The next noble gas to it. So it's ready to lose these 3, and it will now become stable. Now look at carbon. Carbon has 4. There is no element ready to lose 4. Neither is there element ready to gain 4. So carbon will share its electron with other atom. It will share its electron with other atom. But look at nitrogen. Nitrogen has 5. Now, for nitrogen to be stable, it needs 3 to complete 8. So elements like boron that is ready to lose 3 will now come and give that 3 to nitrogen. So when nitrogen gains 3, it will now become stable. The electronic structure will now look like neon 2,8 because it has gained 3. Oxygen will be ready to gain 2 because it has 6. So when it gains 2, that will become 2,8, resemble what? Neon, which is the noble gas next to it. Then fluorine is ready to gain 1. So when fluorine gain 1, it will now resemble neon, which is 2,8. So that is why we say all unstable elements strive to attain stability through chemical bonding. Now look at this statement. Note, after chemical bonding, all elements obey the octet rule. After chemical bonding, all elements obey the octet rule. You now ask, what is the octet rule? Now this is the octet rule. The octet rule states when electron is added, removed, or shared among elements, the remaining electronic configuration resembles the noble gas next to the element. When electron is added, removed, or shared among elements, the remaining electronic configuration resembles the noble gas next to the element. If we go back to this explanation, you will see when hydrogen gains 1 electron, the electronic structure becomes 2, which is the noble gas next to it. Look at boron for instance. When boron loses 3, it will resemble the next noble gas to it, which is helium 2. But look at this, nitrogen. When nitrogen gains 3 electrons, you know it is 2,5. When it gains 3 electrons, it will become 2,8, which is the electronic structure of neon, which is the noble gas next to it. So immediately an element combined with another element, what happened is called chemical bonding. And immediately that happened, that element attain a stable structure. And when it attain a stable structure, it is said to have obeyed the octet rule. It is said to have obeyed the octet rule. And what does the octet rule say? The octet rule states when electron is added, removed, or shared among elements, the remaining electronic configuration resemble the noble gas next to the element. Now, What are now the types of chemical bonding? The types of chemical bonding are electrovalent, covalent, hydrogen bonding, metallic bonding, and van der Waals force. The type of chemical bonding are electrovalent, covalent, hydrogen bonding, metallic bonding, and van der Waals force. In my next video class, we will take all these type of chemical bonding one after the other and treat. The first would be electrovalent. So we'll be treating electrovalent in my next video class. But in this video class, I've been able to show you what chemical bonding is and the reason why elements must partake in chemical bonding, because they are unstable and they need to attain stability, and that is only possible through chemical bonding. There are two types of stable elements. Stable element could be duplet, as we have in helium, and it could be octet, as we have in neon and argon, which means stability with what? 8 electrons. Duplet means stability with 2 electrons. Then I use the first 10 elements to explain stability of an element. Stability of an element. Helium is stable with 2, neon is stable with 8. Other elements are unstable and they strive to attain stability through chemical bonding. Remember, the number of electrons in each of the shell is given by 2n squared, where n is the number of shell. Shell 1, 1 squared, that will be total number of 2 electrons, and shell 2, 2 squared, that will give us a total of 8 electrons. In my next video class, we will start with electrovalent bonding. So long, success.